Welcome to Astronomy Daily, the podcast that brings the cosmos down to Earth. I'm Avery.
And I'm Anna. It's great to be with you. Today, we've got a fantastic lineup. We're starting with our own sun, which just put on a spectacular and slightly terrifying show for our most powerful solar telescope.
Then we're heading into our own atmosphere to a mysterious layer we can barely reach, and the brilliant new technology that might finally unlock its secrets. After that, we'll dig deep into Mars to find out why its insides are as chunky as a cookie.
And finally, we'll tackle the big one, time travel. A new study suggests it might be possible, but it comes with a catch that changes everything. So let's get started.
All right, Anna, let's talk about the sun. We know it can be violent, but this is something else. The NSF Inouye Solar Telescope just got its first look at an X-class flare, and the images are mind-blowing.
They really are. For our listeners, an X-class flare is the most powerful category of solar flare there is. These are massive explosions of energy, and catching one with this level of detail is a huge deal. The telescope managed to capture it at a resolution where the smallest details are just 4 Earths across.
That's incredible. It's like having a super-powered magnifying glass on the most energetic event in our solar system. So what did they actually see with this new level of clarity?
They saw something called coronal loops, but on a scale we've never seen before. These are thin filaments of plasma that arch over the sun's surface, following magnetic field lines. We've seen bundles of them before, but Inouye's power allowed scientists to see individual loops for the first time. Some of these loops were as small as 21 kilometers wide, which is right at the telescope's resolution limit. It's these magnetic field lines twisting, snapping, and reconnecting that powers the solar flares in the first place.
So seeing the fundamental building blocks of these events is a game changer. I know these flares can be dangerous, knocking out radio communications and power grids here on Earth. Does this help us prepare for that?
That's the goal. According to the researchers, peering into these smaller scales, where the magnetic reconnection actually happens, opens the door to understanding the engine behind the flares. Better understanding leads to better prediction models, which gives us a better chance to protect our technology when the sun decides to act up. It's a huge step forward in forecasting space weather.
From the very big to the very, very small. Our next story is about exploring a part of our own atmosphere that's been stubbornly out of reach, the Mesosphere. It's too high for balloons, but too low for satellites.
Exactly. It's a huge blind spot for climate and weather data, but researchers at Harvard and the University of Chicago may have found a way to reach it, and it sounds like something out of science fiction. They've designed ultralight flying structures that float by harnessing sunlight itself. No engines, no fuel.
Powered by sunlight. How does that work?
It uses a phenomenon called photophoresis. It's a gentle force that pushes on an object when light heats one side more than the other. Down here on the ground, the force is so weak we never notice it. But in the extremely thin air of the mesosphere, that tiny push is enough to overcome the weight of these new structures.
So what are these things made of? They must be unbelievably light.
They are. They're built from ultra-thin ceramic alumina with a special coating on the bottom to absorb sunlight. The researchers actually tested them in a lab in a low-pressure chamber that mimics the mesosphere, and they levitated perfectly with just a bit of light.
That's amazing. The applications seem endless. You could attach sensors for climate data or create floating communication arrays like a low-orbit Starlink. One of the researchers even said they could eventually fly on Mars.
That's the long-term vision. Mars has a thin atmosphere that's very similar to our mesosphere, making it a perfect target. One of the lead authors called it the Wild West in terms of applied physics because nothing has ever been able to fly sustainably up there before. This opens up an entirely new way to explore our upper atmosphere and potentially other worlds too. Speaking of Mars, our next story takes us deep inside the red planet. A new analysis has revealed that the interior of Mars is, and this is a direct quote, as chunky as a delicious macadamia cookie.
I love it when scientists get creative with their analogies. So what does that mean exactly? It's not actually made of cookies, I assume.
No, unfortunately. What they found using data from the InSight lander is that huge chunks of Mars's ancient early crust are preserved deep within its mantle. These are geological fossils from when the planet was first forming 4.5 billion years ago.
InSight was the mission that listened for Mars quakes, right? So they used seismic waves to map the interior, like an ultrasound.
That's right. By studying how the waves from these quakes traveled and bounced, they could map out the composition. They found these massive fragments, some up to 4 kilometers across, just drifting in the mantle. The theory is that during the chaotic early days of the solar system, giant impacts shattered the young planet's crust, and those pieces sank into the molten mantle before a new crust formed.
And they've just been sitting there ever since?
Pretty much. Unlike Earth, Mars doesn't have active plate tectonics. Our crust and mantle are constantly churning and recycling each other. Mars has a single solid crust, a stagnant lid. So its interior evolution is much slower. It's acted like a time capsule, preserving this evidence of its violent birth. This gives us an incredible window into what rocky planets look like before tectonics get started.
Okay, for our final story, we're going from planetary history to rewriting it. Or maybe not. Anna, let's talk time travel.
This is a really fascinating one. A new study looked at what would happen inside a spaceship traveling on a closed time-like curve, which is basically a loop through space-time that brings you back to the exact moment you left.
The classic sci-fi setup. So do we get to go back and fix our mistakes? Or accidentally erase ourselves from existence by bumping into our grandfather?
Well, according to this research, neither. The study uses standard quantum mechanics and thermodynamics, not some exotic new theory. And the conclusion is startling. The laws of physics themselves demand self-consistency. After one full loop, everything inside the ship, clocks, computers, and even you, must return to its original state.
So time travel would be like pressing a cosmic reset button.
Precisely. And it gets weirder. To maintain that consistency, the second law of thermodynamics, the one that says disorder or entropy always increases, has to be temporarily reversed. At a certain point in the loop, entropy hits a maximum, and then it starts decreasing. Processes run backwards. Coffee would get warmer. Broken eggs would reassemble.
And what does that do to a person? What about our memories?
This is the biggest catch. The formation of memory is a thermodynamic process. As entropy reverses to bring the system back to its starting state, any memories you formed during the trip would have to be erased completely.
So you could live through this incredible journey, but from your point of view, it would feel like nothing happened at all. You'd get in the ship, complete the loop, and arrive back in the same instant with no memory of the trip.
Exactly. It's the ultimate form of what happens in the loop stays in the loop because it gets completely wiped clean. So instead of rewriting history, you just reset it and forget it. A very different and much less adventurous picture of time travel than the movies suggest.
And that's all the time we have for today. From the fiery heart of the sun to the delicate flyers in our atmosphere, the chunky interior of Mars, and the strange, forgettable physics of time travel.
Thanks for joining us on Astronomy Daily. If you'd like to stay on top of the latest space and astronomy news, simply visit our website at astronomydaily.io and check out our constantly updating newsfeed. You can also find all our back episodes there if you'd like to do some binge listening. I'm Anna.
And I'm Avery. We'll see you next time for another look at our amazing universe. Until then, keep looking up.